Okay, so today we will tackle with this question related to Python basics. So before watching this video, please go on to the basics, revise your basics thoroughly about Python. Okay, so one of the basics question handled by the high school student who are studying coding and all is this one, which is write a method. That means a method indicates that we have to write a user defined function, and the syntax for that is def function name function I'm sorry function name, whatever it is, function name, and the parenthesis. Inside the parenthesis goes arguments, whatever arguments you want. Okay, so write a method in Python to find and display the prime number between 2 to n. What it says that we have to create a user defined function which displays the prime number from 2 to n. N is a user defined variable. You'll input n. Okay, so 2 to n. Right, so what is prime number? I hope you know what prime number is. Prime numbers are the numbers, what should I say? Yeah, prime numbers are the numbers who are divisible by itself and 1. For example, 5. 5 is divisible by 5, that means itself, and 1 only. That's why 5 is a prime number. Okay, and 2 is the smallest prime number. Right, so prime number between 2 to n. Pass n as an argument to the method. I already told you what argument is. So let us first get clear about the concept behind finding the prime number in Python. Right? What is the mathematical tool we will use? What we will use is we'll first create a for loop. So let me just So first step, I'm sorry, first first step is simple. What we will do is, I'm sorry, we'll create a for loop. Okay, and we'll create the for loop for intervals 2 comma n. Right, I hope you know what these intervals are. If you're not clear with these intervals, I'll tell you when I'll write the syntax. Okay, first we have to create a for loop, and then we have to the second step count how many times the number I'm sorry entered number count how many times the entered number uh, is not divisible not divisible from the interval 2 to n. Okay, so what does this say? It says that count how many times the entered number is not divisible from the interval 2 to n. That means we'll count if the number n, which is the number n only, right? If the number n is how many times it is not divisible by the numbers behind n. For example, the value of n is 5. So I'll count how many times the 5 is divisible. 5 is not divisible with the previous numbers. That means 2 to n. I'll explain you again. If it's actually not clear, I'll explain you again. For example, I have a number 5, right? I'll pass n is equals to 5. Sorry, n is equal to 5. Okay, and I'll pass n, and what I'll do is I'll count how many times 5 is not divisible with 4, 3, and 2. Right, I'll count if 5 is divisible by 4, that is not, so I'll count is equals to 1. Is my 5 not divisible by 3, I'll do count is equals to 2. If my 5 is not divisible by 2, I'll do count is equals to 3. Right, if I take here 4, right, and then I'll have 4 comma then I'll have 3 comma 2, right? So 2 to n, right? 2, now my n is 4. That means I have to run my for loop will run till 2 to 4 not included, and that much the numbers between this interval would be tested for divisibility. If n is divisible by the numbers between 2 to n or not, and n in this case is 4. So if n is equals to 4, that means we have to test the divisibility of 4 with the numbers between 2 to 4, that are 3 and 2. So is 4 divisible by 3? No, it's not. So we'll do count is equals to 1. Is 4 divisible by 2? No. Yes, it is. That means our count will make our count is equals to 0. Right. Now here you have to actually understand the concept for prime. Okay, if I pass a prime number, let us take 7, that means I have to test the divisibility of 7 with a 6 comma 5 comma 4 comma 3 comma 2, only till 2. Okay, and I have to count how many times the 7 is not divisible in this interval. Right, is 7 divisible by 6? No, it's not. So I'll do count is equals to 1. Is it divisible by 5? No. Is it divisible by 4? No. Is it divisible by 3? No. Is it divisible by 2? No. That means my count is equal to 5. Notice a weird pattern here, which is my count, which is my count is equal to my n minus 2. Right, I can also write my count is equals to n minus 2. So what you will do is you will extract the number where its count is the number minus 2. Right, if you're not sure that my result or my mathematical pattern is wrong or incorrect, if you have that doubt, you can take another variable or another prime number. Right, let's take 5. That means my count would become n minus 2. That means the predicted count will be 3. Right, so let's test this. So my interval to 2 to n would be 4 comma 3 comma 2. Is 4 divisible by 4? Is 5 divisible by 4? No. So 1. Is 5 divisible by 3? No, it's 2. 5 divisible by 2? No, it's 3. So it becomes 3. That means n minus 2. Right, so I hope your doubts are cleared. Right, so these are the steps. I think this was the final step. You have to check for your count. Right, now let's run back to our coding. So first we have to create our function, of course. So I'll name my function as prime. Okay, I'll name my function as prime. So I'll name it as n. I'll pass n. So what I'll do is I'll create a for loop as I explained. So for I in range 2 comma n. Right, n not included. And what I'll do is I'll add a if condition, that is if my n percentage sign I is not equal to, not equal to 0. So what I mean to extract here is if n percentage sign I means I'm extracting the the remainder. If I write n is equals to 10 and I is equals to 2, and then my n percentage sign I would be 0, because if I divide 10 with 2, the remainder is 0. So it basically extracts 0. Right, so this basically means that if my n is not divisible by the intervals, the numeric intervals, that means it's not equal to 0, then I have to increment y. I hope you understand this expression. If you don't, this simply means y is equals to y plus 1. This is how you use counter. Right, what we are doing is we are incrementing the value of y. That means when the first time, let's take n is equals to 5. Right, so till 2 comma 5, the value of I will vary till 2 to 5. Right, so first it will become 5. So is 5 divisible by 2? So no, so it's not equal to 0. That means y is equals to y plus 1. So for this, y should have an initial value. Right, you're like, y is coming out of nowhere. It's just y is equals to y plus 1. If something is equal to something, if something is equal to the other thing, then that other thing should have a value. But this y does not have a value, does not have any initial value. So you have to initialize y is equals to 0. Right, so it's that simple. Yep, y is equals to 0. I'm sorry. Okay, so y plus, 1. That means my value of 5 would be 1. Then the value of I is turned to 3. 5 is not divisible by 3. That means y is equals to 2 plus 1, and so on and on, right? And in the else statement we'll write y is equal to 0. That if we don't write this, then the value of y keeps on increasing, and we will not be able to count how the y is variating with prime number, right? So it's that simple. What you can do is print y in the end, right? In the end, what you can do is print y, right? Let us call our function, so prime, and we'll input 5. So we should get y is equals to n minus 2, which is 3 in this case. So 3. Let us enter a non-prime number, which is 4. Then we should not get 2. We should not get 2. Okay. Yeah, we are not getting 2. So this is not prime. Okay, 7. So we should get 5. 5. Very good. Okay, so here what we have to do related to the question, if we go back to our question says that we have to print the value of, or print the prime numbers between 2 to n. That means what we have to do is, if my y becomes equal to my n minus 2, as I explained you, if y is equal to n minus 2, then print my n, oh sorry, print my, yep, I should say n, or no, print I. Not print I. I'm sorry, I'm doing something wrong. I should write print prime. Okay, prime. Yep, prime. So it will simply print prime. What I will do is prime and 5. So it will tell us if the number is prime or not. But notice that our question was not asking to check if the number is prime or not. The question was asking to print the number between 2 to n. Right. So the concept behind this is a little different. That means you have to make additions to this code only. Okay, so these additions are very simple. What we'll do is we'll check the value of I and j. Right. For example, take the value of I and j. I is between 2 to your n, which is your range, which would be inputted, right? So I would be the values between 2 to your n, right? In this case, let's take n is equals to 21. So 2 to 21, that means the I would be initially 2, then it will become 3, then 4, then 5, then 6 till 21. Okay, and we'll take another variable, or this would be a variable in a loop. So another variable j, which would be equal to, or which would be in the range 2 to I. Okay, for example, my I has reached 7. Okay, so my I has reached 7, so my j would be a number or numbers in the range 2 comma 7. Okay, so let's take an example of I is equals to 7 and j is equals to 2. Then it will become 3, then 4, then 5, then 6, right? So not 7, 7 is excluded, so till 7. Okay, so my j would be this, initializing with 2. Okay, when my I is equals to 7, my j is this. Okay, so what we'll do is I'll check the divisibility of I and j. What I'll do is check if I is divisible by j or not. If it is not, I'll do y is equals to y plus 1, right? For example, j is 7. So what I'll do is I'll count the value of y. That means is my j is 7, sorry, I is 7. If my I is equal to 7, then my j would be 2 initially. So is 7 and 2 divisible? No. That means my y is equal to 1. Then I'll take I is equals to 7 and j is equals to 3, initializing j. So j is equals to 3, then my value of y becomes 2, because I, 7 and 3 are not divisible. Then I'll take I is equals to 7 again. 7 will remain constant for these intervals. Okay, so then I'll take 7 and my value of j would be 4. Is 7 divisible by 4? No, it's not. So my value of y becomes 3. So similarly, I'll check for this, I'll check for this. So it becomes 7. And notice here that the 7 is 7 minus 2, which I explained you in my just explain you right now. Recently, I explained you in this video only that if my y becomes n minus 2, that means the n is a prime number, right? Here it is I. So let us go back to our code and apply what we have learned. So what I'll do is I'll take another loop, that means a nested loop. So for j in range, the range of the j would be 2 comma I, right? What I'll do is I'll check for I if I is divisible by j, right? What I explained you just now. So if I integer j is not equal to 0, my y will be equal to y plus 1, and here I. So what you have to do is change I to j in the previous code, change I to j and change n to I, right? And here we'll do print I, control S, control B. Okay, there's a error. Oh, I'm sorry, this one. And one more thing, just wait a second. Yep, I hope that's perfect. Yep, that's perfect. Control S, control B. So you see this is the output. So I did till 21. Okay, I passed 21. So you get 3, 5, 7, 11, 13, 17, 19. So you get all the prime numbers. I hope it's pretty clear, and that's it for the video. Thank you for watching, and please don't forget to subscribe. It's free of cost.